We have made it. This is the last tutorial of Unit 7. So we are going to move on from our plane mirrors and we're going to start talking about curved mirrors, and then we're going to talk a little bit about refraction, total internal reflection, and lenses. So this first video will be on curved mirrors, specifically concave mirrors. So there's two types of curved mirrors that we can talk about. The first one being concave. It makes like a cave, so it curves inward, and then convex, which curves outwards. So the first thing we're going to do is just talk about concave mirrors, which you have to kind of think of as a slice of a sphere. So if you've got a giant sphere like this picture on the left, we are just going to take a slice of it. So there's my marker. We're going to take this slice of it and turn it into a mirror. So this is that section, which is a slice of my sphere. And what we're going to be looking at is a couple things. A little bit of terminology to have is that when we look at these types of mirrors, we're going to have a principal axis, which is a line that's going to pass through the center of your sphere. So this is the center of the sphere, and then it's going to hit your mirror. Then we are going to have a center, which we just talked about, which is the radius of curvature. So it's going to be half the diameter or the length of the radius away from the mirror. We are going to have a vertex, which is the point where the principal axis meets the mirror. So that's the vertex. We're going to have a focal point, which is always halfway between the center of curvature and the mirror. And the focal length is the distance between the focal point and the mirror. There's an awesome video sort of just to get you kind of excited about concave mirrors that I will put the link in an email, and I will also put it at the bottom of this video. You can also, if you at home have a giant soup ladle, what I would love for you to do is take your finger and just make it go closer and closer and closer into the ladle, and just see what happens to your image as you change your distance from the ladle. All right, so hopefully you are all inspired to now figure out what's happening. So what we're going to do is we are going to draw ray diagrams, just like we did for our plane mirrors, to figure out what is happening. So hopefully you've watched that video and you see that like his head's right side up and then his head flips upside down and it changes size and all that kind of stuff. So we're going to be figuring out why and when. So when you're drawing a ray diagram, you're going to pick a point at the top of the object and draw two incident rays traveling towards the mirror. The first one's going to be the same as we did before. You are going to pick one that's going to travel. See, this is why I chose keys this time. I cannot draw a straight line. So I'm just going to draw an arrow. So you are going to draw one incident ray that is going to go from the top of your object, and it's going to run parallel to your principal axis. It's just going to make it easier. And then your second incident ray is going to pass through the focal point. So in all of your mirror diagrams, I will have drawn for you one of these things, and I will include in it the center of curvature, the focal point, and obviously the concave mirror. So you're going to go from the top of your object, you're going to pass through this focal point, and then you're going to hit the mirror wherever it hits. So these ones are actually easier than plain mirror diagrams because you're no longer going to have to think about, okay, so my angle of incidence looks like this. I'm going to try to make an angle of reflection be the same measurement. I mean, unless we actually had tools to measure the angle. We're just going to use tricks to do these as best we can. So now we need to draw our reflected rays. So there's going to be two rules of reflection. The key thing is that your angle of incidence is going to equal your angle of reflection, but it's going to be done for you with these focal points. So your incident ray that came in parallel to your principal axis, when it reflects, it's going to reflect through the focal point. So this is your one that came in parallel to your principal axis. And when it reflects, I'll just grab a different pen color. When it reflects, it's going to reflect through your focal point. Then your one incident ray that came in through your focal point, so that's this guy going down here, when it reflects, it's going to reflect parallel to the principal axis. So it's going to do the opposite of what it does on the way in. And what should happen is that the two rays after reflection are either going to converge, and if they do, you mark where they converge, and that's the top of your image, and then you can draw your image. If your rays do not converge after reflection, so for example down here, if you notice that after reflection, so again, let's sort of just go through and make sure you can see where the rays are. So my incident ray, the first one I'm going to draw, is going to come in parallel to my principal axis, and then when it reflects, it's going to go through the focal point. So I moved the location of my object. That's the only way you can get it to not converge after reflection. So then my other incident ray is going to come in through the focal point. Now this is a little tricky because this is my incident ray, but it's almost like you have to draw a ghost line going behind it that would go through the focal point, but then it goes towards the mirror and hits, and then it's going to reflect parallel to the principal axis. So it's going to come out here. So this red ray and this red ray are my reflected rays. And you'll notice that after reflection, they diverge. And so you would extend them on the other side so that they would converge. And again, where they meet is where you would draw the top of your image. And what we're going to be going through is looking at, well, what does that mean? So hopefully you remember from the last video that if your reflected rays converge on the same side as your image, so see how they met here, then you are going to get a real image that's going to be inverted. Whereas if they diverge after reflection, then they converge on the opposite side of the mirror, which means you get a virtual image because you can't actually be behind the mirror, but it's upright. And we'll talk about size as we go through these different ray diagrams. So we are going to go through 1, 2, 3, 4, 5 scenarios with where your object can be placed in relationship to your center of curvature and your focal point. So the first one we're going to start with is when your object is farther than the center of curvature. Now I'm choosing your key to go off of because again, I do not trust myself at all to try to draw a straight line with this pen tool. So I will try to just do my best to sort of guide you through what I've done. But the steps are always the same. You start at the top of your image. I'm going to be consistent and use blue for my incident rays. You start at the top of your image and you draw two incident rays, one running, I'm going to stop trying, one running parallel to the principal axis and one through your focal point. Then from there, wherever they meet the mirror, you're going to have them reflect. And the one that came in parallel to the principal axis is going to reflect through the focal point. And the one that went through your focal point is going to reflect parallel to your principal axis. Now looking at this, I can definitely see I didn't do the best job of parallel. I'm looking for the best you can. Okay, and then where these two reflected rays meet is where you're going to put the top of your image. Then we're going to describe the image. Since the image is on the same side as your original image, your reflected image is on the same side as your original image, it is a real image. Real images always come out inverted, which means upside down. And then this image is smaller. So maybe go back and watch that video after we've done this of that wonderful man at the front of his lecture office sort of looking at himself in a mirror with the center of curvature and the focal point on the floor and looking to see what happens to him. And when he's past the center of curvature, you get a real image, which is inverted and smaller. So then the idea behind this one is that this is one for you to practice. Oh, I did a horrible job. Should never look at my keys in this size. But this first ray, I didn't do a very nice job, but should be a little more parallel. Oh, look, that's not bad. Hey, I did it. So your principal ray or your incident ray should come in parallel to your principal axis. And then your reflected ray is going to go through your focal point. Oh, see, that one's not as good. But it should be something. Yeah, see, and then it doesn't do what I want it to. So I'm going to erase that. This is why I was using the keys. Okay, so you have your incident ray. The first one is going to come in parallel to your principal axis. The second one is going to come in through your focal point. Okay, and then you've got your reflected rays. So the reflected rays, I'm going to grab my red pen. The one that came in parallel to the principal axis is going to come out through the focal point, and the one that came out through your focal point is going to come out parallel to your principal axis, which again, I'm not very good at drawing a parallel apparently. Oh wow, and I'm doing that opposite. Sorry, the orange one is my reflected image. This is hard with doing it on keys. Sorry. So this guy down here, I was wondering why my arrows were going all funky. So let me just start that again. Sorry if you were drawing along, or maybe you were sitting there going, Karen, you're saying it wrong. So this is my original image. My first incident ray is coming in parallel to my principal axis. My second one is going through the focal point. And then I'm going to get my reflected rays. So where they hit the mirror, you're going to get this reflected ray. The first one that came in parallel is going to go through the focal point, and the one that came through the focal point is going to come out parallel. And then where these two reflected rays converge is where your image is formed. And again, because the reflected image is on the same side as my original image, it's a real image, it's inverted, and it's smaller. All right. Next one. This one is brutal. I think I had to erase and redo this one about 100 times to make it perfect. But what it is that now we're going to move our object into the center of curvature. And when your object is at the center of curvature, you're going to follow the same process. So we are going to have one incident ray go parallel to the principal axis, one go through the focal point. Then wherever they hit the mirror, you're going to have your reflected ray. So you're going to have your incident ray that's parallel come out through the focal point, and you're going to have the one that went through the focal point come out parallel. And where they meet is where your image is going to be. Now it should come out exactly the same size, and it should be real image, which is inverted, and the exact same size at the exact same place when you're at the center of curvature. Really hard to get that to come out perfectly, but you should know sort of that's what should happen. Scenario number 3 is when your object is between the focal point and the center of curvature. So we're moving in. We've been beyond the center of curvature, we've been at the center of a curvature, and now we're between the center of curvature and the focal point. So what's going to happen? Well, we're going to follow the exact same steps. So we're going to have our incident rays. We're going to have one coming in parallel to my principal axis. We're going to have one come in through my focal point. Then I'm going to draw the reflected rays. So where they hit the mirror, this first one up top is going to come back out through the focal point. The one that came through the focal point is going to be reflected parallel to the principal axis, and where they meet is where your image is going to be formed. And again, you're going to get a real image, which is inverted, and this time it's going to be larger. So we went smaller, same size, larger. This next one, I'm glad I used the highlighter so I can tell which one's my original image and which one's my reflection. We're going to do the exact same thing. So from the top of my original image, we are going to have one incident ray come parallel to the principal axis, one principal ray incident ray come through the focal point. Then we're going to have our reflections. So when your one that came in parallel reflects, it's going to go through the focal point. And then when the one that went through the focal point reflects, it's going to come out parallel. And where they converge is where my image is going to be formed. Sometimes you have to extend your principal axis to help yourself out. But again, you get a real image because it's on the same side as your original image, which is also inverted, and it's larger. All right. Step number 4 is when your object is at the focal point. So we are going to draw this, but again, I wouldn't ask you to do this one on a test because it is pretty hard to get right. So the first one I'm going to do is I'm going to draw an incident ray that is parallel to the principal axis. Then I would like to draw one through the focal point, but that would be straight up and down. So there's no way of doing that. So I've just drawn another incident ray, and I chose to draw one just like we did with the plane mirror, where it hits the mirror because, and where the mirror hits the principal axis, because I can use this rule still. This still does lie. My angle of incidence is still going to equal my angle of reflection. It's just by doing it this trick way through the focal point, you don't have to actually think of that very much. But if you can't draw a line through the focal point, then you have to. So my incident ray that came in parallel is going to go back through my focal point, and then my one that hit my principal axis is going to come out. And what should happen is that these two lines will never meet, which means that an image cannot be formed because you are getting no converging of the reflected rays. Even if you extended them the other side, they would still run parallel. So there is no image. The last scenario is when you have your object closer than the focal point. So you're going to draw your two incident rays the same way we did before. You're going to draw one that's going to come in parallel to your principal axis. Then the other one's a bit tricky because you want it to leave your top of your image and hit the mirror, but to go through the focal point's behind. So what I do is I just take my ruler and I line it up through the focal point, but I only draw this section here just to reduce the number of lines that I have on my page. So I've got my two incident rays. Now I want to draw my two reflected rays. When you reflect them, the one that went through the focal point is going to come back out parallel, and the one that came in parallel is going to come out through the focal point. And you'll notice that on this side, the two rays diverge away from each other. So what you're going to do is extend them on the opposite side of the mirror, just like we did with the plane mirror diagrams, and where they converge behind the mirror is where your image is going to be formed. But because they're going behind the mirror, you are getting a virtual image. So you can skip down to the bottom if you want here, but you're getting a virtual image, which is upright and it's larger. So again, rewatch the video of the guy in the front of his lecture room, or pull out a ladle and watch your finger going towards the ladle, and you'll see all of this happen. It'll be inverted and smaller, then it'll be the same size, then it'll be inverted and larger, then it won't exist for a moment when you're in the focal point, and then all of a sudden you'll be upright. So all of a sudden you've switched from being inverted to upright and you're larger. And so try this last one and see if you've got it. Again, I always recommend pausing videos and trying these on your own as we go. But we've got the one incident ray going from the top of the image running parallel to the principal axis. Then I hold my ruler on the focal point and just have my incident ray coming through the top like it would have gone through the focal point. Then I draw my reflected rays. The one that came in parallel goes through the focal point. The one that came in through the focal point goes out parallel. They are diverging on the same side as the image, so they will converge on the opposite side of the mirror. And so you get this virtual image, which is upright and larger than the original image. So there's an overview again on real versus virtual with ray diagrams, just if you really aren't getting it or you just want like another example of how this happens. The next thing I just wanted to talk about are what are some uses of these concave mirrors. I'm just going back to your original note. I think I had some pictures that I put in here. Good. So I've got some links as well. But uses of concave mirrors, we can use them for shaving mirrors. So if you want to get up close, so as long as you're close to the concave mirror, so if you have one of these in your bathroom, if you stand far away, you're inverted, but the closer you get, eventually you get this upright image, which is virtual, and it's going to be really close up. So if you want to shave or you wanted to, I don't know, look at your nose hairs or something like that. Another use of this that I thought was actually pretty interesting, it's this old school diagram on the right here, which is called a head mirror. And I had to look this up what it was, but what it was is that they wanted to really focus rays so that they could look. So this, I think, has an example of a guy looking up somebody's nose, but they wanted to really focus the light so that it really pinpoints and they can see what they're looking at. So you'll notice up here in the right-hand side, they have a light source. And these light rays are going to come in and hit this concave mirror. And when they bounce off, they're going to converge. And so they all come in and they converge to this one focal point that he wants to look at. Headlights and flashlights do the same thing. So they have all of these rays that are coming in to hit the curved inside of the headlight, which would be a reflective surface. And then instead of making them narrow, they make them go parallel, and so that you can increase the intensity of your light. All right, hope you've enjoyed concave mirrors, and come back for the next video and we'll do convex mirrors.